Okay, so I wanted to clarify a couple of things. One of them was the first video. It was one of the guessing games I made that was like this one. I think it was the second guessing game. That one works, and I changed it up from this, and that one, I ran it on my calculator and downloaded it, and I would show you guys, but actually it would be really difficult to get a camera and hook up the editing software, and so you can take my word for it, or you can ask your friend who has a Ti-84 calculator or a Ti-80 or Ti's calculator. It should run this program. All those functions should work. The syntax might be a little different, but that one works. And then there was another one that was similar to this is actually the derivation of it, the other one before. And then the other one, the one where I had an if statement. Ooh, no, don't copy. I had an if, and then I had stuff, and then I had then, and then I had else, and I had stuff, and I had if, and then at the very, very end I had two ends. That one doesn't work. I could go back and retranscribe it and then debug it, but to me that wouldn't be worth my time, as I'm doing other things, like making this video, and then there's physics. So actually I want to talk about a little bit of the, not really physics, it's actually an application of that program, but a lot of the programming, in my view, isn't just the equation, or knowing what the commands actually do, but it's knowing how to use them to solve the problem that you have. Yeah, we'll delete that. So for example, it was here. This looks kind of complex, I bet, and to me it still kind of does, because this is kind of mind-bending, but the issue was I had 5 different variables, and so this was actually originally 5, but I'm going to try and rewrite it as a Pythagorean theorem, I guess equation, or solver, and where you don't have to use a menu. And so there's actually a way you can get around that by using strings. And so first I don't display label 2, that's weird. Okay, so first off you have to have a disclaimer of what the inputs are about. So unknowns are y. And so if you have an unknown, like A, B, or C, then input the answer as y. And then if you know what it is, put it in as a number. And usually you can't do that, because if you use prompt, or if you try and store any string, like any letter, to a no, where is it? There we go. To a variable like f, it will throw an error. If you try and store a number as a string, so if you put it in quotes to a variable, it will throw an error. If you put 7 store f, then it'll work, because you're putting 7 as a variable, and that works. So that's why you have to use strings, which is the beauty of input. So you're asking, okay, what it is, because otherwise if you did prompt string 3, it'll ask you what you want the value of string 3 to be. It's like, well, you don't really know what the meaning of that is, and so it's unknowns are y, okay, and then you'd have the title, which would be Pyth theorem. So unknowns are y, okay, great. And if you don't know a, for example, then you put it in as y, and then you put in the value of b and the value of c, and then you have string 1, 2, and 3, which have the respective values. And so then you have to look for, actually we can delete this, the specific instance in which you are solving for a specific variable. And so if you're solving for a, which we know is y, so string 1 is y, and then you're checking if string 1 is y, and the only instance that string 1 would be y is if you're solving for a. And so then you can actually solve for a with the actual code. And so this actually is as complex as it needs to be. Just rip this whole line out. There we go. And so what you're doing is, first off, you have to have the then, because you're running this block of code, not just a single line. And then you have to convert the string to an equation, which is what that arrow means. And then you have to give it the string and then the equation respectively. And so the string that I want to convert to an equation, because right now whatever the value of b is a string, and you can't work with strings, you can't multiply a string by 2, because it's just not going to work, because you can't take numbers and then mix them with letters. Algebra would say differently, but programming is somewhat different than algebra. So then you're converting string 2 and string 3 into y2 and y3. And so then actually here is the equation. And so that's actually from the physics program I was working on, but you have to call on them the same way. And the reason that you have this y2 of 0 is because you're looking at the function of y2 at element 0. And so you're evaluating, it's much like you've taken algebra or something. Not algebra. I guess algebra. No, not algebra. What's it called? I forget the names of it. But it's if you have f of x, and then you also have that, which is like the y, and then you have the actual x. So if you put in x at 9, then you'd have f of 9, right? And so you evaluate whatever the function of f is at 9, and that's what I'm doing here, except I'm evaluating it at 0, because it's a constant, right? So I'm not putting in b as 3x, it's just 3. And so it's going to be a straight line across a graphing screen if you actually graph it. And so here displaying y2 of 0 would just display whatever you put as b, because b is string 2 is now y2, and y2 is of 0 is just y2, which is like, I don't know, 5. So we don't want to display just what the value of b is, we want to display what the value of a is, but we don't know what the value of a is, so we have to take, okay. And here's where it gets fun, because you have to make sure you don't screw it up with all the parentheses. So you have y2, which this bit right here is just b, don't forget that. So we can get rid of these because we're going to be adding, actually, no, we need this to be y3. So this needs to be y3, and then we're going to need to subtract y2. Oof, that's not what I want to do. There we go. y2 of 0, because we need to give it a place to evaluate at. And then we need to square that and put another parentheses around it. And so this should work. And I haven't checked it yet, so I don't put check. And then that's how you do comments, by the way. If you run this program just as it is with that line in there, it shouldn't display that. It shouldn't. I did it in another program and it did, and I was kind of confused, but it shouldn't, because that's a comment. And so if you just put it in quotes by itself, it just won't it's a comment to the writer or the reader of the program, not the calculator who could be running the program. Alright, so then you should be able to run this, and I will do that and get back to you next time on how that works. But if you want to run a program without menus, and you can run a program without menus, you could do it like this if you're looking for specific values. You could actually apply this to probably a lot of other programs that you're looking at. That's enough for today. If you guys have any questions, comments, concerns, whatever, just leave them. You should be able to. I don't know if you can optimize this, but again, leaving the challenge out there. If you guys can optimize any of these, do let me know. Any questions? Check out the first video I had, and I did forget to link that video to that guy who showed me the program clear. But I will try and do that this time. Anyway, have a nice day, and thank you.